Hey guys, hope you all doing well. Welcome back to my channel. So today I'm going to show you guys an easy experiment, and what we're going to use for this experiment is an Arduino UNO. Now an Arduino UNO is a microcontroller on a PCB. It allows you to code and control voltage flow or current flow in a circuit, allowing you to turn an LED on when maybe when an input comes in. And so this experiment will show you guys the basics of the Arduino. Now over here with the Arduino UNO, I bought the Arduino starter kit. So it has a bunch of jumper cables, a stepper motor, an LCD, ultrasonic sensor, 8-segment displays, relay, battery pack, and remote control, and a lot of these things. So if you guys are interested, you can just search for Arduino starter kit. It has a breadboard and resistors and a lot of electronic components. So if you're interested, I'd say it is very good for beginners who are trying to make circuits and things like that and learn about robotics. So without waiting, let's start. So today with this Arduino UNO, now there are many Arduino boards out there. There are many advanced ones and very simple small Arduino boards also. Now the Arduino UNO is just a starter board, but they all basically do the same thing, and they are basically just based on size and what you want to do with the board. So to teach the basic principles of Arduino and how it works, we're going to make an LED distance indicator. So the things that we need: first, an Arduino UNO, ultrasonic distance sensor, a breadboard, 7 LEDs and 7 1k ohm resistors, and then a few jumper wires. So now we are going to start the connections. Now before that, you need to know the connection way on the breadboard. Now here there are these two sides on the breadboard. Now here all of these pins are horizontally connected on both the sides, and then here on all the rest of them the connection is vertical. It can go downwards or upwards, but one thing to remember, after this slit the connection does not continue on to the other part of the breadboard. Now knowing that, let's start the connection. So we're going to start with the LEDs. Now here the LED has two terminals, an anode and a cathode. Now what we're going to do, we'll take the positive is the long side, the long one. Now we need the negative, so we'll take the negative of the LED and we'll put it over here on the negative of this side, and have the other terminal go on to the positive and connect it just like that. Now we are going to connect the 1k ohm resistor. So how? Let me show you how to connect. So we are going to take one terminal of the 1k ohm resistor and put it on the part that is right in front of the LED, and then the other side we'll put it onto the cross the slit on the other side of the breadboard. So like this, and we are going to continue doing that for each and every LED. So I have connected both the LED and resistor. Now it's time to connect the ultrasonic sensor. So what I'm going to do is I'm going to connect it over here. Make sure it's not on the same row as the resistors, but make sure it's behind the resistors, and just put it in. Now before we connect the jumper wires and connect it to the ultrasonic sensor, the ultrasonic sensor has 4 pins. It has a VCC, a ground, a trigger, and an echo pin. The VCC is the pin for power, to make the ultrasonic sensor work. The ground pin is also for power, and then there's the trigger pin and echo pin, which is for input and output. Okay, so now I'm going to connect the jumper wires to the ultrasonic sensor. jumper wires and we are going to connect it to in front of each and every resistor. Now we are going to connect one jumper cable to the end of this negative place, so the ground connection goes to all. And now we are going to connect all of these jumper cables to the Arduino. Now we need to connect the jumper cable that is connected to the VCC. We will connect it to the 5-volt pin. That to 5 volt. Then we'll take the pin that is connected to the ground and give it straight to ground. This should be connected to 5 volt. And then here we have the echo pin and trigger pin. The echo goes to pin number 12 and then the trigger pin goes to pin number 11. And then we will take this other ground that we connected, we will connect it to this ground here, and then all of these LED jumper cables will connect it from pin number 2 up to pin number 8. Now I'm going to connect the Arduino to the PC because all our other jumper connections are done. Okay guys, so I have finished the connection. Now it's time for uploading and writing the code. So before I'll have the code in the description, but before I upload the code, I want to explain it to you guys so you understand it a little bit. Now over here we have a few constant integers. You can see const int meaning constant integers, meaning we are telling it that these are numbers that we want to save in another way. So instead of writing 11 and 12, we are going to have them as the trigger and echo pin. If you guys remember, trigger was in pin 11 and echo was in pin 12. So instead of writing 11 and 12, we can just write trigger and echo, and then the same thing from LED 1 to LED 7, and the way it has been mapped out. And then there are these integer durations, meaning they're going to change, they're not constant, they're just integers. And because these are the durations and the distance that the ultrasonic sensor is monitoring and detecting. Now here in the main void setup loop, we have to see which pins are inputs and outputs. Now here trigger is going to be an output and echo is going to be an input, and then all our LEDs are going to be an output. And then we're going to begin our serial terminal, which is going to begin from 9600. And then after that, in our loop, void loop, we're going to first give the trigger high voltage, and then delay it for 1000 microseconds, and then give trigger low voltage again, just to make sure it works. And then now we're taking the input from our echo pin and we are monitoring it as duration. Okay, and now duration is a special type of thing, because now here sound travels at 343 meters per second. Now we're going to have to convert it into a number that we can understand in centimeters value. So to do that, we're going to divide that by 2 and then divide it by 28.5, and that is going to be our distance. And then here I have the serial to print the duration variable. So if any of you want to know what the duration is, you can check serial terminal, and here on serial monitor in your Arduino IDE, you can open it and you can find it. And then after that, you have a few if statements, which is the ones that run the main part of the distance indicator. Now here we are telling it if this distance, which is in centimeters, is less than or equals to 5, so 5 centimeters, we are going to have LED 1 raised to high. Okay, and then is else if it is not less than or equals to 5, we'll have it a low voltage. and then the same here. If distance is less than or equals to 7, LED 2 is high, else digital write or change LED 2 to low, and then we continue doing that. And so that's it for the code. After that, all you need to do is click on the upload button and then you're done. Okay, so I've uploaded the code. Now let's test. So according to the program, the first LED is 25, second is 20, 17, 15, 10, 7 and 5. And then as I go back, it will also take place. So that's it for today. I hope you like the video. So this Arduino is a very good thing for people who want to do coding, robotics and electronics and mechanics and all of that. So I'll have more videos based on this, more interesting, more fun videos. So I'll see you in the next video. Bye.